Just want to welcome you. My name is Barry Morris. I head up a number of the database services in AWS, notably non-relational databases. Work very closely with a number of the other or with all the other database leaders in the organization. So I just wanted, what we're going to be talking about today is about databases. Of course, data is the foundation of AI, and operational databases are the foundation of data. And most of our customers are going through a sort of a journey of migration onto the cloud and onto cloud databases. And this is quite a fun thing for us to talk about because Amazon's been through this ourselves. Amazon.com, not too many years ago, was running essentially on relational database technology. And it got to its limits. And so what we've done subsequently, if you look at the Amazon web page today, the Amazon.com page, behind that application is many databases. There's search technology that's driving the search. There's key value technology that's driving the customer feedback stuff. There's graph technology that's driving the recommendations, and so on. And we'll talk a little bit more about that in a minute. So this is a journey that we've been on ourselves. We want to talk through really sort of what it means to modernize databases on the cloud. I'm going to give you a little bit of an overview, and Venki's going to give us a bit of a deep dive. So, excuse me. The first thing is about these modern database applications. The requirements are these. First of all, agility, because your business is agile. You've got a need to move your business forward. Unlike old-style applications that would be built rather like a bridge, they'd be built and you move on and build the next bridge. Today, applications are live. You keep working on them. You move as fast as you can. And so agility is absolutely key to it. The second piece, scale, is actually the primary thing that drove Amazon to move to notably adding or at least DynamoDB into Amazon.com, because every time that we came to a big retail day, we had to do enormous planning to make sure that the relational databases could keep up with the likely peak load. Since we put DynamoDB in there, we've never had to even plan for it because it just scales. And so that's really the essence of this whole kind of modernization thing. If you use the right database for the right thing, you get the performance, you get the agility, and so forth. And lastly, of course, getting to 24/7 availability, even under situations of system failure or of extreme load, etc. So these are the sorts of requirements for modern applications. And traditional applications don't typically do that. On the left, you see the sort of typical application stack that's been around for a couple of decades. And you've got a presentation layer, and you've got a business logic layer, and you've got a storage layer, kind of three-tier type applications. These are exactly the applications that people are running on premises and which don't tend to scale very well on the cloud. Of course, where we're going to is what's on the right. You've still got those same basic layers. They're all very different. Presentation layer is probably much more mobile-oriented. It's much more, it's voice-oriented. It's natural language-oriented. Perhaps it's targeting special devices, set-top boxes in car, and so forth. But it's the middle layer that's had the big change, which is that we've moved towards microservices and to sort of disaggregated applications running on Kubernetes or whatever. And the goal there is that every piece of the application can not only scale independently, but that it can have separate teams that are working on it, and they can be going through their CI/CD deployment pipelines independently. And so you start getting that kind of application velocity that's absolutely at the key of it. And of course, at the bottom, each of those microservices will tend to use not only their language of choice and their frameworks of choice and so forth, but they'll tend to use the database of choice. And for some of them, it's going to be a MongoDB-style document database, and for some of them, it's going to be relational, and some of them, it's going to be key value. For many of them, there's going to be a cache on top of it. And what you've got is an architecture that doesn't look anything like that monolithic architecture that you had on premises. Additionally, if you've historically been selling software to on-premises customers, so you're an ISV in other words, and you start wanting to serve that application as a service on the cloud, you've got this issue of multi-tenancy. And really the sort of multi-tenancy thing is that the naive way is that you're going to simply fire up an instance of that application stack for every customer. And that's what you've got depicted here. Lots of people do this. It's got various strengths and weaknesses. Single biggest weakness is that you're probably going to over-provision for your smallest customers, and it's going to cost you a lot of money. The alternative at the other end of the spectrum is to have multi-tenancy, full multi-tenancy, where all your customers are sharing the same application image and database instances and so forth. That's hard to do as you're going through this whole process. That's something, if you're going to be doing that, that's a big piece of work that's going to be part of your modernization. In fact, a lot of customers end up with, or a lot of our customers will end up having a mix of those two things, because their largest customers have got so much more in terms of their needs that it makes sense for them to have dedicated infrastructure and then the smaller ones to share. And so there are advantages and disadvantages to these two sides of it, but the main message from the point of view of modernizing applications and certainly moving on-premises to the cloud is think about multi-tenancy up front. It is a big part of the need. We mentioned Amazon, Amazon.com. This, as I say, is something which is enormous scale. The numbers of transactions that we have to deal with on a busy day are measured in trillions per day. So very, very large data loads. And we moved from this monolith, we moved to a microservices-style architecture. Organizationally as well, of course, what we did is the typical Amazon thing of having small teams, what we call two pizza teams, a team that can be fed by two pizzas, driving each of these microservices. And so now you've got something where, as I mentioned earlier, we don't really have concerns about scale anywhere like we had before. We feel that we can cope with whatever the peaks are on a particular day because of the modernization that we've done. And lastly, just before I hand over to Venki, let me just sort of picture for you what a typical journey looks like for a customer. Typically people will start from the bottom left, and they're moving from on-premises to probably to EC2. That'll be a kind of a lift and shift movement. They're running essentially the identical technology, but now on the cloud. They get a lot of benefit from that because they can do things like provisioning quickly or move to a bigger machine or add another location or whatever. And they get onto both of these arrows, the one of which is the arrow of innovation velocity and the other of which, of course, is cost management. And they're onto that. And there's some customers that are happy to stop there. But really what we've been talking about in terms of Amazon and some of the more advanced customers, they're getting to the far end. They've moving to managed databases where they no longer have to do the sort of what we call undifferentiated heavy lifting of running those database services and doing the backups and the patching and everything else. We'll take care of that for you. Once they've done that, quite often people that came onto the cloud running on a commercial database will feel, well, I don't need to do that. I can actually run on Postgres or on MySQL or something, so let me move away from that. And ultimately moving to modernization, which is adding Elasticache because you can do that on the cloud and it's much harder to do on premises, or adding Dynamo, or adding whatever it is, moving DocumentDB in because you've got content management to do, and so forth. So really, that's what I wanted to do by way of introduction. I'm going to hand over to Venki, and he can take us into a deep dive.
Thank you, Barry. So, perfect. So let's take a look into the pathways for modernization. So what you have learned is customers would like to modernize as they migrate into the cloud, right? And as you all know, modernization is not a process, it's a journey. And you may have different compelling reasons to migrate, and most of the common reasons we hear from the customers are data center exit, or end of hardware software licensing, or simply for cost savings. And the board of directors, CTOs, CFOs are no longer expect cost savings. Although you do expect to save at least 25 to 50% when they move to AWS, when you compare it with on-prem. They would also want to transform the customer experience. They would want to digitally transform the business. And most importantly, they would want to reinvest that cost savings back into the innovation cycle. And that is very important. And for that, you cannot modernize just the database alone, right? You have to start with the application no matter what. So when you start building, right, you have to analyze your existing portfolio of applications. Now, a lot of customers, we have learned that they start from the scratch by building brand new applications. Mostly they use serverless as their building blocks. And basically they are technical debt free, right? And then they look into the existing portfolio of applications. They will try to either reduce by retiring their applications that they no longer want, or they try to consolidate by moving into multi-tenancy. They try to SaaSify their applications. Then most of the customers would like to do a lift and shift, or they migrate to AWS. And the last pattern is the modernization, right? This is where you would see refactoring and replatforming, and this is where we're going to spend some time on it. So here is a slide which is probably quite busy. But then let's start from the left-hand side, or right-hand side to me. So that's the application. You have databases and Windows, right? The first step that most of the customers would like to do is rehost, right? You can rehost the application into the cloud on EC2, for example. But then there are requirements from the customer where they do not want to move into cloud, probably due to some stringent requirements. They can go for public cloud. If public cloud is not an option, then you can go for AWS Outposts. That is an option for customers to run AWS infrastructure on-prem to get a full hybrid experience. And then when you want to completely refactor and replatform your applications, you can move into more of a cloud-native architecture, as you see on the screen. So let's say you have to build an event-driven architecture or applications that were already being event-driven, you can go for Lambda, right? And then you can go for containers, especially if you have any VMs, you want to move into cloud, you can go for containers, especially they're great for monolithic applications, or let's say that you want to run and deploy long-running applications. Then let's say you want to have more of a controlled environment where you do not want to spend time on managing. You could go for ECS, which is, again, a managed containerization service where you can run, deploy your containerized applications. You also have Fargate, which is a compute engine for managing your containerization. Then you have EKS, where you can, again, manage your containerization applications. Again, that is based on open source Kubernetes. So that's there. So from a developer perspective, they would like to have more agility, right? We do have applications like CodeStar, where developers can build deployment workflows on AWS. And for continuous delivery, you have code builds, code pipeline, and so on. Then moving into the data layer, this is where you have move to managed and move to open source, where either you're going to move from, let's say, SQL Server to RDS SQL, or let's say you want to move away from SQL Server to Aurora Postgres. So we will spend some time into the next few slides there. So what are the common patterns that you'd normally see from the customers, right? So let's say you have like thousands of environments at your on-prem, and you want to make an inventory. The most challenging part is you need to do a manual auditing to find out what your data sources are, how many databases you have, and so on and so forth. That could be a task which could take months, right? In order to make that job easier, we have a tool from the database migration service called Data Collector. So with that tool, it's automated. It's going to collect all your inventories. Probably in hours, you're going to get a list. And that list will have all your environment with the versions, the database size, and so on. So you could make an informed decision of okay, which database I need to start with, and so on and so forth. Then let's say you have commercial engines like SQL Server and Oracle Server, and you want to make a decision, okay, I want to do a migrate to an EC2, or I want to move into RDS. The first option most of the customers see is EC2. Obviously, they use native tools to migrate. But let's say they have some restrictions and they're unable to use native tools. Then you have DMS and SCT. What it stands for is Database Migration Service and Schema Conversion Tool. So the Schema Conversion Tool is probably the first step, where it's going to create an assessment report. And if you're unsure, let's say I don't know where to migrate to from SQL, should I pick MySQL or should I pick Postgres? Then schema conversion tool would give you an assessment report. And that tool is going to tell you, okay, this is the best target because the level of effort for you to migrate is probably the least. So with that, you're going to make a decision. And not only that, it's going to also help you do schema conversion. It's going to do code objects conversion. And the most important part is the data migration, which is taken care of by TMS. And for minimal downtime or near zero downtime, it also helps with data replication as a part of DMS, what we call it as CDC. The first pattern is pretty obvious, that is move to manage. So let's say you have an on-prem SQL, you then do RDS SQL Server, which is pretty straightforward. You can use DMS and SCT or native tools of your choice to migrate, which is great. And just before going there, you might wonder, what is the benefit of moving to a managed service? Like Barry said, managed services are great if you don't want to spend your time on undifferentiated heavy lift, like provisioning, patching, upgrades, security, and so on. So RDS, as a managed service, we give you that experience so that you can focus on innovation. The next pattern which we commonly see from the customer is break free. That is, I want to move away from SQL to something else. And this is where SCT is going to help you. It's going to create you this assessment report, and you're going to move from there. So in this case, I picked Amazon Aurora. So for those who is not aware of Aurora, so this is compatible with both MySQL and Postgres, which gives you 5 times more performance than vanilla MySQL and 3 times more performance than Postgres. And the best part is, the storage is distributed, it's automatically scalable, and so on and so forth. So I have 2 more elements there, which I will cover after this. So that's the Babelfish. Again, for those who is not aware of Babelfish, moving away from SQL Server to, let's say, Aurora Postgres is a task on its own, right? It's time-consuming, it's resource-intensive. But with Babelfish, we have reduced the downtime or reduced the effort. So what it means is, let's say you can keep your applications that are written for the SQL Server, Postgres can able to understand. So basically, it can able to understand both T-SQL and P-SQL. So for the new codes that you're developing, you can continue writing it on P-SQL. And for the existing codes, you can take your time to convert. And until then, you can continue to use your T-SQL codes. So it's basically a machine that can understand both languages. And the last most popular option is the purpose-built database, because what we understood after working several years with the customers is that there is not one database that suits for all your use cases, right? There isn't a database. So although Amazon DynamoDB is what I've used in the screen, there are multiple databases which I will be talking about in the next few screens. And before I go there, I want to talk about Aurora Limitless for a bit. So relational databases can only scale to an extent, right? Whereas Aurora Limitless gives you an option to scale almost infinitely, right? With the writer in Node, for example, you can almost able to achieve 1 million transactions per second. That is unbelievable for a relational database. Yes, you can able to achieve that with purpose-built databases. But from a relational perspective, normally you are bound to hit some of the capacity or the limitations, which we have taken a feedback and worked on a new tool that is Aurora Limitless. So within this modernization pattern, right, what we have seen is adding this caching. Yes, you can work with the databases. Normally what happens is the data is going to be fetched from the disk, which is an expensive process. We're going to put it into the memory, and then you're going to read it from the memory, which is all right. But then as you keep doing, that is going to add performance penalty to your applications. But let's say your developers need microsecond latency as a basic requirement, then the relational databases can't do justification, right? And this is where AWS has given you an option. That's Elastic Cache and MemoryDB. Now, Amazon Elastic Cache is Redis and Memcache compatible. So persistence is an option, so you can enable or disable, and it gives you microsecond response times. And on the other hand, Amazon MemoryDB is fully compatible with Redis, and it's a persistent in-memory data store, right? So you get microsecond latency for reads and millisecond latency for writes. And keep in mind, you can use this database as a persistent in-memory data store, especially where the application is sensitive to latency. This is great. And as you see, you can achieve scalability and agility with the help of a purpose-built database like Elastic Cache and MemoryDB. Then the second sub-pattern, again, for non-relational, for the purpose-built is the non-relational query patterns. Yes, you can scale to an extent with the relational databases, but what if you have a requirement where you have to have a high-performant application that has to scale infinitely, right? Such as Amazon.com. When you have this Amazon.com sales, like Prime Day, for example, just to give you a stats, Amazon DynamoDB was able to serve 45 trillion requests a day. So that is 45 million requests per second. 7 trillion requests a day, and then 45 million requests per second. So that's a lot. Imagine, we don't expect customers to be scaling of that size. But what I'm trying to say is, you have a service that can be able to scale that much. So DynamoDB is built for key-value database. And like I said, it can be able to perform at any scale. And so if you have a use case where your developers needed, you can go for DynamoDB. And the second popular engine is the DocumentDB in this diagram. So again, this is a purpose-built database for the data document model. So let's say you, as a company that's working on a lot of documents, be it nested documents, that you'd want to query the document or index the document, then doing it on a relational database is probably time-consuming, right? You have to normalize that. You have to fit it on a relational table, and that's not going to scale well. And this is why we have come up with Amazon DocumentDB, which is fully compatible with MongoDB. So which means any APIs, drivers, application codes that you are using already with MongoDB, you can be able to use it with Amazon DocumentDB. And some of the benefits, again, same as what we've seen before: scalability, agility, and performance. And the last is the specialized data sets, what we call. So these are like unique cases, right? So let's say you as a company that is working with highly connected data sets. Let's say you are a company which has millions of followers, and you want to establish a relationship between the followers and, let's say, an athlete for a sports store. Then, the graph database such as Amazon Neptune is a great fit for your use case. And for time stream, imagine you have a data set based on time that's constantly changing, and you have like GBs of data that's getting ingested per minute. Obviously, a relational database can't do justification for that. Especially when you want to create index on a relational database for that size, the indexes are going to be a bit clunky, right? So you don't, it's not going to scale well. So this is where Amazon TimeStream is going to come in really handy. And this is a database where you can ingest tens of GBs of data per minute, and you can be able to query that in fraction of a second. So that's the whole purpose-built diagram with different use cases. And now let's see what customers do, let's say, after migrating, right? So you have your applications. Now, as a customer, you have made your case, you have migrated, you have probably modernized some of your databases. The next step is what to do with this data, right? And data is the foundation, right? So you would want to move some of the data from the transactional engine to the analytical engine, and probably beyond for AML innovation. And for that, what you've seen is, customers normally have these developers. They would want to use new services. But most of the times when they want to use this new service or a plugin, they would have to re-architect the whole stuff. That's a challenge. So what you've done is, we have provided a lot of service which could use like a Lego-based. So you can introduce a service anywhere, you can build a pipeline, and you can move the data around. So for streaming, we have Amazon Kinesis and MSK. And for batch ingestion, you have services like TMS, you have Amazon EMR, and you can use open source big data frameworks like Hive, Spark, Presto. And you also have Glue, where you want to do an ETL kind of extract, transform, and load. And then you move your data, build your analytics or your data lake of that sort. And then from there, you can do a visualization using Amazon QuickSight, which is a business intelligence tool. Or you can stream it back to other backend applications. Or you could basically use this data to build, train, and model your machine learning LLMs. Right? That's where Amazon SageMaker comes in handy. And you do also have Bedrock. We have a separate track for that, so I'm not going to dive deep into that. And one other area which I would want to highlight is the Zero ETL here. So Zero ETL is another platform that's going to help you move your data with a click of a button from your analytical database, from your relational database to the analytical database. So from Amazon Aurora to Redshift, you have the Zero ETL integration that works smoothly. Our next session is on Zero ETL, so I'm not going to jump too much into it. So you can wait and listen to the next session to get more about it. So these are some of the Zero ETL features that's available as of today. And again, it's easy. Your developers don't need to spend time building this whole pipeline, and something breaks. You don't want to spend time on investigating and fixing it. We made your life easier. And what's even interesting is, quite recently, we have made a new feature where you can take control over your source database on which tables that you want to migrate it from OLTP to OLAP. So that's more on the next session. And if you want to go serverless, obviously, you have a lot of options on the application. And here is a snapshot of the application from the database side. You have all this that's highlighted in white, or the database layer, of course. So you can use serverless offerings here. So what's next? Yes, you have migrated, you have modernized, you have innovated. What's the next popular pattern that we have seen, right? With this whole generative AI era, we have seen vector databases. So before I come in here, I want to talk about this slide. I will go to that one later. So I probably have seen this slide before, but I would want to focus just on the vector data store, right? So vector data store is an emerging thing, especially that supports this generative AI applications. So again, we have a separate topic running on this vector, but just to give you an overview, let's say you as a customer are presented with a prompt. You enter a question, and you're looking for an answer. So what it's going to do is it's going to look into the LLM, and it's going to fetch, and it's going to provide a context as an output. But what if the data that you have trained was trained on, let's say, 3 months ago? Right? And there's a lot of data that probably has been populated right after that. And if you asked any question of up-to-date data, probably you're not going to get any up-to-date information. So how are you going to tackle it? And what we call it as hallucination in AI world. So in order to tackle this hallucination problem, you have this RAG-based solution, or retrieval augmented generation. And to support that, you have vector data store. So basically, you're going to create embeddings, and you're going to store into a vector database. An embedding is nothing but a format that machine can understand to train. So with this, what it's going to happen is, with all the new data that you're getting from the right-hand side, we're going to create embeddings, and we're going to put it into the vector data store. And for the questions that's being asked from the user, we're going to use the context, and we're going to do a similarity search. We're going to get the context, and with the given input, we're going to add this additional context to the ground LLM so that it gives you an accurate information. And this is where vector databases are popular. So now I'm going to go back to the previous slide, and then I'm going to jump onto that. So you might wonder, why having this vectors and data store are important? Why do you want to keep it together? Yes, you do have a separate vector data store. But then, as a developer, you don't want to build another pipeline to move your data from your data store to another vector data store, right? You want to keep everything in sync so that you avoid this data movement. Your developers probably will have to learn a new language or create new APIs and so on and so forth. So you're going to avoid all of this if you are keeping your vector and your databases together. So to make that easier, I want to move now on to the next one. Sorry for that. So we have all of these services that you on the screen that supports vector database. Now, many of you have already used, or some of you have already used this service. So we have vector data store support in all of it, right? So you can continue using your database as you do. And then if you have a new functionality or if you are building a new generative AI application, then you can continue using the vector data store in this service. So now, what are the tools that's available? We have spoken about everything. Now, what are the tools that's available? So you have DMS Fleet Advisor, which you've already seen, that helps you basically doing an inventory analysis, and you can create a business use case, basically, to perform this migration. And you have schema conversion tool that helps you assessment report, schema conversion, code conversion, and so on. And the database migration service itself, which would help you to remove the data and helps you replicate. Then we have folks like us, SAs, partners in the room and outside. And again, internally, we have DMAs. Then you have a lot of other programs which you will be hearing throughout the session here in other areas, so I'm not going to spend much time on it. And we spoke about schema conversion tool, so I still had a slide here. So why is it used? Like I said, create this assessment, convert schema, code objects, and not only for relational database. As you see on the far right, it also helps you extract data warehouse data to Amazon Redshift. So what source and target to DMS support as of today? So here is a snapshot of that. And this list is growing, so you can take a picture, and when we show this, probably you'll have new sources next time. So when we speak with the customers, right now, we start with the data flywheel. I mean, you may have a different data flywheel, but then we work with the customers, we create their own custom data flywheel. And if you notice, it's made up of a few key initiatives. And one key initiative doesn't work on its own. It has to be a combination for the business to grow in long term. So the businesses that actually focuses on each part of this flywheel has a long momentum, right? This is where AWS will work with you, our partners will work with you in creating this flywheel, and we help you succeed. So what are the takeaways? Like I initially said, modernization is not a process, but rather a journey. And you can use the pathways and decide, where do I start and where I am? And then from there, you can move your next step, because it's a journey, like we said. And with the tools that we have shown, from AWS as well as from partners, you can start planning your migration and modernization journey. So we have a lot of programs. Again, you would be seeing this in almost all the sessions, but just to give you a high-level overview, if you need peer-level executive guidance, we have data strategy team. So they are basically a former CXOs from large enterprises. We will team you up with those members, and we can help you create a business use case. And we have D2E, or data-driven everything, which is, again, a program where we'll work with your C-level, and we'll create a business use case or ideation day, and we will help you achieve that for a long-term progress. Then you have Reimagined Data, and you have AWS Generative AI Innovation Center, where we will, again, team you up with folks with the skill set on that particular domain, and we will help you achieve what you want to build in the next innovation cycle on the generative AI. And with that, I'm going to conclude the presentation. Thank you very much for listening to us patiently. I appreciate that.